Do I have to? You know, Andrew, I'm glad you dressed for the occasion. You didn't even know anybody was coming in to videotape, but you wore your math shirt today. I am impressed. It's kind of ironic, right? All right, so we've been talking about polynomials. Our biggest goal today is to be looking at polynomial graphs and kind of look at the characteristics of them, okay? So we're going to start off talking about some terminology. If you guys want to see what they're doing. I do. I made it. I knew it was coming today. Yep. I don't know if you want to see, but you can have a copy. So we have to cover some terms first, all right, and then we're going to use those terms, identify some features about polynomial graphs. All right, so let's start off just talking about a couple terms here. All right. Are we ready, guys? Mrs. Mackey's more impressed.
Color.
Which color are we missing?
3 of 5. Oh, never mind.
I'm like, we may not have ever had one. I have no idea until, I don't know. All right, let's write down these definitions right now, and we're going to apply those here in a few minutes. So let's write down a leading coefficient, the coefficient of the term with the highest degree. The coefficient of the term with the highest degree.
Can you see the board okay?
All right, then the other definition I want you guys to write down is the degree of a polynomial is the value of the greatest exponent. So the value of the greatest exponent. We all good? All right, so this next table here, we're going to apply these definitions to this table. So it says complete the table to summarize the degrees and leading coefficients of various polynomials. I want to start down here, okay? All right, looking at that polynomial, I want you guys to look at the definition for degree and write down what you think the degree of the polynomial is. So we're looking at the cubic, this one down here. Look at your definition of degree. And then write down in this box right here what you think the degree of the polynomial is. So we all should write something down. So just as a reminder, degree, it's the value of the greatest exponent. We all got something down? Some of us have moved ahead. A lot of things down. All right, Austin, what did you put down for the degree for that? All right, you put down 3. So my pens aren't working. All right, so 3. Why did you pick 3? What about the definition told you that? All right, you're looking for the greatest exponent is what he said. So the greatest exponent when I look at all of these is 3. Good job. All right, so now we have to find the leading coefficient. So if I go back again, leading coefficient, it's the coefficient of the term with the highest degree. So if I look at this polynomial right here, what would the leading coefficient be? Write that down on your paper. So why'd you pick that one? So it says, let me ask you guys a question real fast. I know we've used this term before. All right, when it says coefficient, what does that even mean? Number where? So I'm going to pick a different problem, okay? So if I pick a problem here, let's say I pick this one. Can you give me a coefficient?
5.
5 is a coefficient. So a coefficient is the number in front of the variable. That's what they're asking you guys for. So the coefficient of the term with the highest degree. All right, Nick, what did you put down? 8. Why did you pick 8?
It's the highest number or the highest exponent.
Correct. Here's our highest degree right here. What is the coefficient of this highest degree? So we focus on the highest degree, and that coefficient was 8. All right, let's go backwards. Let's do this one now. Write down what the degree is, knowing what we just did here. Write down what you think the degree is and what the leading coefficient is. All right, Jeremy, what did you get for the degree? 2, good. Natalie, what did you get for the leading coefficient? Good. All right, highest degree was this one right here. All right, that's why we picked 2 for the degree, and the number out in front was 5. So that's your leading coefficient. All right, so if you've done the next one, do the next one. Just above it. Yeah, I'm like backwards in my mind because you guys are going backwards. All right, Sam, come and help me with this one. What did you write down for your leading coefficient? 1. And then what did you write down? I'm sorry, your degree. I pointed to degree and said leading coefficient. That's right, 1. And then what's the leading coefficient? 4. All right. Look at this one now. Looks pretty good to me. Write down what you think the degree is, and then write down what you think the leading coefficient would be. All right, Andrew, what did you write down for the degree for this one? 0. Why did you say 0? All right, so what if I put x to the 0 power? What did we say the other day that what would be like 5 to the 0 power?
0.
Not 0. Type it in.
1.
Sure. Type it in.
No, it's -5. Yeah, it's 1.
All right, it's 1. So if you have something to the 0 power and it's just 1, remember how we talked about how we could just cancel it out? All right, so that's kind of why my degree is 0. So then what would my leading coefficient be? 12. The number in front of that leading degree would be 12. All right, questions about that? All right, do these next 4. Degree and leading coefficient. And this is what I normally do. Just so I know which is which, I usually put D equals LC equals. Okay, so if I'm going back to this and I need to use my notes, I want to make sure I write stuff down so it's descriptive. And be careful. I wasn't as nice to you guys this time. I didn't always write everything in descending order, so be careful. Right here, when I say state the degree, I look at all these terms, and the degree is the largest exponent. So what's the biggest exponent I have here? 9. Right, so I would write D for degree equals 3. All right, now that I've picked this, the leading coefficient is the number in front of that variable where I just boxed off. So what number is there? Yeah, so that would be a 7. Okay, so let's come down here. What would the degree of this one be? Yep, so write that down. And then what would the leading coefficient be? But it would be? Negative. There you go. Easy as that. That's all you missed. Makes it kind of nice. All right, man, some of you guys are like well ahead of me. All right, Marcus. For this first one here, what was the degree? 3. And what did you write down for the leading coefficient? 7. Good. All right. Noah, what did you write down for the degree of this one?
5.
Okay, so look at it really hard. So I tried to trick you and I tricked you. It's going to be 6 because the degree is the highest exponent. So I didn't write mine in the right order like you guys should. So then if that's the case, what should the leading coefficient be? But there you go, -8. All right. Megan, can you help me with this one? No, you just got back. What's the degree for this one? 6. And what about the leading coefficient?
5.
Good. Then Nick, what about this one here? What's my degree?
6.
Good. Good. So that's -1. So double check that you guys put -1 there. Okay. So now our goal is to use these ideas, all right, to look at some of these graphs of these polynomials. Now, it may help to put arrows on these sometimes. We're going to go to the first one together. The first 4 graphs we look at are even degree graphs. So we're going to try to figure out what the characteristics of an even degree graph is, because eventually we're not going to give you the equation. We're just going to give you the graph, and then you have to go through and answer these questions. Okay, so that's going to be our goal. All right, so let's start off with this, the degree here. Natalie, what's the degree of this equation? 2. Keep picking on you for a second. So is that degree even or odd?
Even.
It is even. What would my leading coefficient be?
1.
Good, 1. So plus, plus, plus. All right, so now this is something new. End behavior. It's about how the graph is behaving at the beginning of the graph and the end of the graph. So this one here is telling us to start when x is approaching -infinity. All right, which axis is the x-axis? The bottom one, what's that mean? Right, the horizontal one is the x-axis. So if this is the x-axis right here, which part of the x-axis am I referring to as -infinity? The left side or the right side? The left side, because isn't that where the negative numbers are, the left side? All right, so then that would make that be +infinity. So see if you can answer this. Your answer for this over here is either going to be negative or positive infinity. So if we're looking at negative infinity on this side of the graph, what's happening with y? So how do I know it's positive infinity? What about that, Noah? Okay, so your graph is going up, right? So if I look at the y-axis here, all right, this is my y-axis if that's the x-axis. What part of the y-axis is positive infinity? Bottom or top? Top. So that would be positive infinity for the y-axis. That would be negative infinity. So if I look at when x is negative infinity, here's my graph. Which way is the arrow pointing on this side? Up. So it's pointing up. Like you said, no, it's pointing towards positive infinity. So now if x is positive infinity, so look at that part of your graph, then y is what? So which way is my graph pointing on this side? It's pointing up still, isn't it? So it's still going to be positive infinity. So it's about the way the graph is pointing. So in this case, the graph was pointing up here, and the graph was pointing up here. All right, so answer the rest of the evens on that page. You have to put arrows on your graph so you can see where the arrows are actually pointing like I did on this first one. Check your papers. Kids usually sit back at the top sometimes. Yep.
Right.
4. Mm-hmm.
How would I?
Okay, just look at your arrows. So I like to label my axis. I like to put negative infinity here, positive infinity here, like I did. Okay, so when you looked at negative infinity, which way was the arrow pointing on the graph?
That one.
So how about on this side, which way is it pointing? Yep, so it's at
Positive.
Mm-hmm. Keep going. It's way too easy. You don't know. Okay, so when I labeled this, I labeled it on the x-axis, but this is fine. Okay, so when you label this, the left side is negative infinity, the right side is positive infinity. Okay, so on this side of the graph, which way is the arrow pointing? So here's the graph here. So on this side, which way is the arrow pointing? Up. So if it's pointing up, do you think that means negative or positive infinity? Mm-hmm. And then when I look at this side, which would be the right side, so negative is left, this is this way. All right, which way is the arrow pointing on this side? Up, so that should be what? Yep, so if they're both pointing up, they're both positives. Okay, keep going. Yeah. Looks good to me. Nice job. Nice job. All right, so let's just double check. I know we walked around and checked your answers, but let's just double check to make sure you guys have it all copied right, because we can always miss something. All right, so Jeremy, can you give me the answers for all of the second one? What was the degree? 4. All right, is that number even or odd? All right, what was the leading coefficient? 1. And then when I look at my end behavior, negative is on the left, positive is on the right. So what was y doing? Positive infinity. And then what about when x was at positive infinity, what was y doing? Approaching positive infinity. Good. All right, let's look at the next one. All All right, let's see. Natalie, what was the degree for this one? 2. Is that number even or odd? How about the leading coefficient? -1. Okay, so again, if I label my x-axis, as x is going to negative infinity, what's y doing? Good. Because my arrow this time was pointing down. And then as x is approaching positive infinity, what's y doing? Good. Because my arrows were pointing down. All right, last even degree. So let's see here. Andrew, what's the degree? 4. Is that number even or odd? Say again, sir. Even. What's your leading coefficient? Good. All right, so if I label my x-axis with negative and positive infinity, what's y doing when x is approaching negative infinity? Good. And then what's y doing when x is approaching positive infinity? Good. All right, questions about the even degree ones? All right, so let's keep going. All right, again, you guys can keep going with this. If you need to put arrows on to help you, put arrows on to help you. For which one? Second one. So if I'm on this side, which way is the arrow pointing on the graph? Up. So then, yeah. Now, if I'm on this side, which way is the arrow pointing? Down. So what should that be? Okay.
Like, is that right?
Good, good, good. Good, good. You guys are quick.
Thank you. It's easy.
It's too easy for you?
No, really.
I'm going to try to stump you, so keep saying that, okay?
I always miss like the littlest thing. I miss 5 on the second question.
Happens to all of us, though, you know.
I know, but
It's okay.
I just.
Yeah. Okay, yeah. So, where is x negative infinity? Can you point to that part? So we're on this side of the graph. Which way is the arrow pointing on this side of the graph? Down. Correct. And then when x is positive infinity, which way is the arrow pointing? Up. Okay, so on this graph here, where is, I'm looking at the end behavior, so where is x negative infinity on this graph? Right here, right? So on this side of the graph, the left side of the graph, which way is the arrow pointing? So if it's pointing down, is it pointing to positive or negative infinity? Yeah, we gotta look at where the arrows are going. So then when x is positive infinity, which way is the arrow pointing? Yeah. So go back and look at your end behaviors. Okay? I think you understand now. Did you get checked already? Not yet. Good, 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 good.
Yes.
Good, 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 good. Looks good. Did you get checked already? Not all of them. Did you get checked? All right. Take a 5-minute break, guys. Need to pause it.
Bailey Goff, please go.
All right. Noah Blanchard, can you help me with this one? Third one on your paper. Good. Is it an odd or even number? Leading coefficient. So as x is approaching negative infinity, what was y doing? Yep. And then as x was approaching positive infinity, what was y doing? Yep. All right, Marcus, you want the last one? Okay. What was the degree?
385.
Good. Is that an even or odd number? Leading coefficient? Good. And then as x approached negative infinity, what did y do? Good. And then as x approached positive infinity, what did y do? Negative infinity. All right, so we're going to take a break from this packet for a second. All right, well, hold on. I didn't say put it away. All right, take a break from writing in the packet. What I want you guys to do is go back to the even functions. So turn your page back to the even functions. And I want you to look at the characteristics of even functions. Once you think you've studied the characteristics of even functions enough, I want you guys to go to the back table. You're going to pick up one graph that is an even function, and you are going to tape it to this side. Now, most of the graphs have tape on them from my first spell today. If for some reason the graph you pick up does not have tape on the back of it, there's tape right here. Okay? So go ahead. You gotta tape it up there. You don't get to keep it. Come on now. And then you want to decorate your locker with it. Yeah. Yeah.
I didn't even see it.
Just doing evens.
No, it's the equation, not the graph. The equation, not the graph.
That one?
Yeah, I was looking for one that went up, so.
Oh. All right, so if you guys look at these, all right, so look at each one of these carefully. It's kind of hard to see from where you are a little bit. All right, I tried to make them as big as I could without making them too big. Are any of these not even functions? This one here? All right, so John thinks this one's not even. What do you guys think?
I think it's even. No.
All right, let's talk about this for a second, okay? All right, so we're going to look at even functions to start with. What made you guys pick the graphs that you picked?
They all went center.
Meaning what?
And they both went down and up.
All right, so either both arrows went down, is what Marcus said, or both arrows went up. So I didn't draw arrows on these at all. That would make it too easy for you guys. So let's look at this one here.
Had the same end behavior.
Oh, I like that. I like that a lot. Have the same end behavior. So does this graph have the same end behavior?
Yes.
Yes, because what direction are both the arrows pointing? Down. All right, so even degree of functions, and I'm going to use those words, Marcus, I like that. They have the same end behavior. So I'm not writing this in the box quite yet. I'm writing it above the box on your paper, so you guys can write that down too. So we say they have the same end behavior. Can somebody give me an example of what that means? Marcus, I think, said it before. I need you guys to re-explain it to me again. What does it mean to have the same end behavior? All right, so give me an example of what that means. I agree with you. Be specific.
Like it points the same way it starts as an end.
Okay, so give me an example. Which way could it point when it starts? Good. And then and when it ends, it would point which direction? All right, so very good. So if it started pointing up on one side, the other side has to point up. So what's the other alternative we have? Say it again. All right, so Where it starts, it points down, and where it ends, it points down. All right, so now we made it easy for you guys, all right? But you still going to want to look at the odd degree functions that we went over. So go back to those odd degree function graphs, look at them, because there's still some even ones back here. There's not many. There are still some even ones back here. We want you guys to pick up an odd degree one and tape it to this side.
No, they could either both be up or they could both be down.
So they just both have to be on the same direction. For a second.
The other way. Do you need more tape? Well, sometimes it's just like when we pulled it off, it like ripped. You know what I mean? The first bow. So yeah, if you're missing tape, it's not a big deal. Yeah. All right, so I'm going to look. Do you guys see any of these that are incorrect? Takes me a while to look. I think we're good. All right, so now, again, Marcus said before, even degree functions have the same end behavior. All right, so somebody else besides Marcus, tell me about the end behavior of odd degree functions.
They go the opposite way.
Okay, so. All right, so for odd functions, all right, the end behavior goes in opposite directions. All right, so now I need to be a little more specific here. What does that mean, that the end behavior goes in odd directions? So give me an example of what that could mean.
One goes up, one goes down.
Okay, so one goes up, one goes down, or what else, Noah?
That's what I was gonna say.
But what would the opposite be?
One goes right, one goes left.
Well, our end behavior either went up or down, right?
Yeah.
So what's the other one I could put here? Put here.
One goes down, one goes down.
There we go. One goes down and then one goes up. All right, so now we're going to get more specific, okay? So if I look at we're going to start with the evens again. How do I know, and do not say anything, you're just going to think to yourself for a second. Look at your even degree functions. Look at these even degree functions. All right, how do I know if my arrows are going to both point up, or my end behavior is going to go both up, or if my end behavior is going to both be going down? So think about it. Don't say anything. So again, it might help to look at that. I mean, you can look at these, but I think it helps to look at the ones in your packets. Look at the even degree functions in your packet. How did we know, or how can we look at those things and determine if my end behavior both goes up or if the end behavior both goes down? Oh, hold on. How do I know? Don't shout it out, okay? I'm going to ask for the answer here in a minute, but I'm going to give her a chance to think, okay? All right, so who thinks they know? No? What do you think?
Leading coefficient.
Okay, so the leading coefficient is going to tell us whether both my end behaviors go up or they both go down. All right, so tell me this. Look at the leading coefficient for those four graphs. What kind of leading coefficient did we have if they both went up?
Just 10%.
A positive leading coefficient. What happened if they both went down? Negative. All right, so what I want you guys each to do is you're going to come up here, take one graph, and then either put it on the plus side or the negative side, just for the evens. And you can take your same graph or you can take a different one. I don't care. We'll talk about odds in a second. Okay. All right, so let's take a look at these. Sometimes I guess they're a little hard to see, but do we think we have on the right side? We have the positive on the positive sides, the negatives on the negative sides? All right, so if I go back to my even table here, all right, so if they're both going to have an end behavior pointing up, when does this happen?
Positive coefficient.
Causative, not just put coefficient, but what's the other word I need? There we go. We need a positive, and I'm going to write the word out. I know I abbreviate it sometimes, but I might forget what LC stands for. And so what do you think we should write down here for this next box?
Negative.
Right? A negative leading coefficient. All right, you guys ready for the odd degree ones now? All right, so let's look at the odd degree ones. What do you think determines whether it starts up, pointing up, and ends down, or starts down and points up? What do you think we look at?
A, I guess.
Oh, okay, what did we call that? We gave it a vocabulary term today. What did we call that?
Some?
Okay, so let me give you guys a second. So go look at all of your odd degree graphs and try to figure out, how do you know if it's going to be like this, where it's high then low, or low then high? What determines that? You can like whisper it to me.
Right here.
Not necessarily. I want to know why it ends like that. Like, what about it tells me it's going to end like that? Hey, who thinks they figured it out? Andrew, what did you figure out?
The leading coefficient is a positive, it goes down on the negative side.
Okay.
And then after the leading coefficient is negative, it goes down on the positive side.
Okay, so we're using the leading coefficient again. Just like we use the leading coefficient here, we're using the leading coefficient here to determine if it starts high, ends low, or starts low and ends high. So look at your leading coefficients for those 4 graphs in your packet. And look at those graphs. Then I want you guys to come up here. Pick a graph. This is not easy. I think I can stump you guys. Can I stump you? Pick a graph and put it on the correct side. Make sure the graph is right side up. Make sure the y is the way it should be. It's not upside down. Okay? When you're ready, you think you know, you take a graph and move it.
I know.
It's okay to talk about it, guys. It really is. Just can't phone Mrs. Mackey or myself.
So just look at what they're doing so far and try to figure out the pattern.
Okay.
Yeah.
All right, it's kind of hard to see, so I'm going to put tape on the back of this. All right, so go ahead and look what's up here, guys. Phone's away, phone's away. Said you couldn't phone a friend. All right, so look at the graphs that are up here. Do you guys agree with which ones have a positive leading coefficient and a negative leading coefficient? So they all in the right spot? Okay, so you want to go up and move that one, Noah? So I know which one you're talking about? There are a couple that are off, and that's okay. We're going to talk about this. Okay? What else do you guys see? Okay, so go ahead and go move it. And we'll see if you guys agree or not. Somebody may move it back, who knows? Anything else you guys want to move? You guys think you're good? All right, so then tell me, if this is my end behavior, is this leading coefficient going to be positive or negative? Oh, come on now, let's look over here. How many of you guys say negative? How many of you guys say it's going to be positive? For this top one. Positive? So this right here looks like these graphs here?
No. Wait.
You're all right. Which one do you think it is? Okay, some of you guys didn't even answer. All right, so the leading coefficient is what? Negative. Good. So what am I going to write down here? Yeah, leading coefficient is positive. This is not easy for odd degree functions, is it? It's easy for even. They both go up, it's positive. They both go down, it's negative. So I need to come up a way to make it a little bit easier. Does anybody see anything that might be a good strategy for remembering this for odd degree functions? Andrew, go ahead.
One looks like a regular N and one looks like a backwards N.
Huh? Okay. Okay, so you're saying like this one here would be the backwards end?
Yeah.
This would be the frontwards end? Okay. What do you mean when it points to the
Like
right?
if it's on the right side, like I don't know.
Yeah?
I just looked at it, I see an arrow on the positive side of the graph that is negative.
Which way is the arrow going to point on the positive side of the graph?
Like if it's going up on the other side.
Okay. That's a good one. So he says if it's pointing up on the positive side of the graph, then it would have a leading coefficient that's positive. It's pointing down on the positive side of the graph. The leading coefficient is negative. So that's not a bad strategy. I like that. All right, can I show you guys my strategy? Okay. So I connect the arrows. Every time I see a graph, I connect the arrows. If I connect the arrows and make a line, what would the slope of this line be? Negative. So since the slope is negative, guess what? And then if I connect these arrows, what would the slope be? Positive. So that's how I remember it for odd degree polynomials. I think I got that when I worked with Tara Willick. I think she told me. She came up with that. All right, now, for these here, this is where we're going to end in our notes. It says, use the degree and leading coefficient to match each polynomial to its graph. Do not graph on your graphing calculator. It'd be hard to do anyway because you probably wouldn't be able to see them. So I got to know. All right, so let's look at this first one right here. All right, Jeremy, this first one, letter A. Is this an even degree or an odd degree? It's an even degree. So that narrows your answer choices down. Okay? That's all I'm going to say. You guys try to match them. Match the graph with the equation.
Oh, wait, never mind. I was thinking positive.
Like they better not be.
I was looking at positive and negative.
There you go. Okay, so what's the degree of this polynomial? 3. And you just told me this was even. 3 is an odd number, so it can't match. Okay? If you think you got it, let me know. You got it? Nice job. Not easy. Not quite. Let me see real fast. Let me see. So, this was what?
This was here.
Okay, but what, like, is it, when Jeremy said this to me, did he say it was an even degree or an odd degree?
Even.
Even. What's the degree on this?
Even.
Is it?
Wait, is the degree?
Degree is the highest exponent,
Yeah.
which is what?
Oh, odd.
Yeah, so that can't match. Okay, let's see here. Okay, so let's see. So these are both even. I agree with you. So I agree that these two are even. So which one of these has a leading coefficient that's positive?
This one?
Okay, so is this leading coefficient positive?
No.
No. Okay, so what did we match this to now? Okay, good. Good. So what's my degree on this one? 2, which is even, right? So you matched to C. C is not even. So you need to flip these two.
Is this right?
So B, what kind of degree is this function going to be, even or odd?
Oh.
Okay, so you have to pay attention to.
Fix it.
Okay, so let's see here. A, is this graph even or odd?
Even.
And what's my degree on this?
Even. 3.
Is it E? Is 3 an even number? Last time I checked, it was not. Good job. And then here, let's see.
Wait, an even number. Oh.
So if it's even, it's got to point in the same direction.
So right here?
Okay. So what are you missing now? So C. C or even or odd?
Even.
Well, that's even. That's odd. So let's write down. Write down all of these, even or odds. Write E and O. Okay, so these are both even. So which ones are your evens on these?
That one and this one.
So these are two choices. These can either be
This
A
is
or B. It's which one? I'm sorry.
B.
Correct. Which then would make 3B.
Okay.
Okay, so then now figure out these two. They're both odds.
This is C.
Is it what? I'm sorry.
C.
Yes. Do we not check somebody? Good. I checked you. Nice job.
So even degree or odd degree.
So what are the
All right, so now, this is what I need you guys to do now. So listen. All right, your exit slip. All right, we did not get through everything, which is fine. So on your exit slip, do not answer the number of real roots. Do not answer that. And do not answer at the very bottom maximums and minimums. I mean, if you want to see if you know it, you can try it. Don't cross it out too hard because we are going to answer them tomorrow. So when you're finished with your exit slip, bring it up here and grab a homework.